there and welcome to this session, Bridging the Gap Between Developers and Security. My name's Simon Maple, I'm the Field CTO here at Snyk today. And today we're going to be talking about a few things, including the security impact of cloud native applications. In this modern development age where we are building applications for the cloud, how does the security aspect impact developers going through that stage? Next, we're going to also talk about the introduction to security champions. What is a security champion program and how can we use it in our development programs to assist us with that developer adoption of security? And of course, empowering developers is one of the things that Snyk is all about. So we will also talk about how Snyk can be introduced through a security champions program. Now, we hear shift left a lot, and shift left is a common and quite familiar term that has been used for many, many years. It's also used in security, and shift left is really about that process of testing, finding and fixing vulnerabilities faster in the process as well as earlier. Now, there's more to it than just the time aspect when security is run. DevOps encourages that fast-moving team aspect whereby development teams are independent and autonomous. And that means that they have fewer external dependencies effectively on other teams, such as security and operations. So one of the core aspects of that means we need to empower developers instead of thinking just shift left in time. So we need to think shift down to our developers, to our practitioners. Now, security teams also need to enable those development teams, and what that means is providing education around secure development practices as well as guardrails and being available for whether it's discussion, consultation, as needed where exceptions and edge cases exist. Now, Snyk as a company has built a platform purposely just purely around this vision. As a developer tool, that's really fast so it can fit into workflows without slowing down development teams, being accurate enough to reduce developer frustrations around false positives, being actionable in terms of its results, and allowing developers to see that fixed path. So we make the right thing to do also the easy thing for the developer. On the other hand, existing security solutions which traditionally try to retrofit their tooling that's designed specifically for security teams tends to be built for compliance purposes onto developers. Now, this is a flawed approach that we've seen time and time again, which fails to gain developer adoption or acceptance, increasing frustrations, not fitting into developer workflows due to the conflicting priorities based on the tool's construction. So let's now take a look on this slide, which gives a great representation of how our industry has changed, both pre-cloud moving to a cloud deployment. So on the left-hand side here, we can see what a pre-cloud deployment stack looks like. At the very top, you can see app code, as well as third-party libraries that we pull into our application. Now, these are in purple, representing the fact that it's part of the developer's scope. What they sit on is this stack, which tends to be owned by a platform team or an operations team, and this can include things like virtualization, network concerns, servers, VMs, and so forth. If we wanted to make changes to that platform, probably we're looking at 10, 15 years ago, we would tend to need to raise a ticket, and that ticket would go to an IT or an ops person that would make the change, perhaps opening a port or so forth. On the right-hand side, we can now see this post-cloud world whereby a lot of those interactions have changed into APIs. Instead of deploying onto VMs, we tend to deploy into containers. And those artifacts that describe those containers and the infrastructure tend to be configuration, which get deployed into change repositories, into Git repos. So now, as developers, the scope of our application has changed. You can see what is purple now, including things like Kubernetes config and those kind of things. These are concerns of the developer as well as potentially other roles within the organization. As this stack has changed, a number of the risks that get associated are kind of similar. If a port is open on the left-hand side and a port being open on the right-hand side, the risk in the attack vector remains similar. However, the way we need to approach the security testing and the security fixing changes. So what does this mean for developers? Well, what we see on the left-hand side here requires an IT security solution, whereas on the right-hand side, we see an AppSec solution. Snyk as a developer focus lends itself to the AppSec solution. Now, on this next slide, the Snyk platform addresses the security needs of this modern cloud-native application with the following AppSec solution. You can see on the left-hand side, we have this wonderful iceberg representation of what constitutes the cloud-native application. And there are various pieces of here. The piece at the top of this iceberg is the piece which we as developers tend to see most often, which is the first-party code. This is what we see in our IDE of choice. I'm not here to judge you, but that's the code that we write ourselves, that we see in our IDEs, and we tend to want a static security scanner that will look at that code and inform us not just of where issues exist, but how to fix. This is what Snyk code does. Then below that, under the covers, we can see third-party libraries, and those third-party libraries provide known vulnerabilities. They introduce known vulnerabilities into our application, and this is what Snyk open source does, looking for known issues as well as license issues, and provides them to developers with remediation advice. Then beneath that, as part of our application, as part of our modern cloud-native application, we care about how we deploy that. And one piece here is containers. We deploy into containers, typically maybe Docker files or something like that, which development teams can write themselves or update template files. And these containers can have a number of different vulnerabilities which are introduced through packages in the operating system level or key binaries that are added in. And Snyk Container can identify them, as well as providing remediation advice based on some of the best base images and parent images that you can use, as well as more information on those vulnerabilities and how to fix. And then last on this slide, we can see infrastructure as code. Now, Snyk infrastructure as code scans in a static way, similarly to Snyk code. In a static way, it looks through the configurations, Kubernetes config, Terraform config, those kind of things, and identifies well-known issues, security issues, and misconfigurations that are added. This is one of the core concerns and core areas that we've seen incidents in more recently. So that is the modern application. Now, on the next slide here, we're going to look at how this scanning, these testing, can be introduced to your pipeline. And one of the core reasons which really differentiates Snyk from competitors here is that focus, that obsession with developers. And that means really providing a first-class solution to developers on that far left. So looking on that far left here, we can see developers at the time of coding in your IDEs, whether you're using CLIs, whether you want to use APIs, providing that insight early on. Then as we go further right, looking at Git repositories, being able to provide and scan in your integrations in your GitHub, in your GitLab, in your Bitbucket, these kind of areas, as well as being able to monitor those repositories and provide pull requests as we find new issues that affect your existing projects. And then going even further in your CI/CD, being able to identify as your applications are being built, security issues that exist there, all the way through to being able to monitor, as I mentioned, code that is running in production. Ultimately, we're trying to provide all of that as information to that left-hand side. Now, as developers here, we tend to sit more on the left-hand side. Security tend to look a little bit, closer to that right-hand side in production. One of the core things is how we achieve that collaboration. So, on the next slide, we see here that collaboration is extremely important, and DevOps processes, one of the core areas of DevOps processes is that it supports the collaboration and the communication between dev and infra or operations teams. And DevOps processes really demand that, sometimes many times a day. DevOps practices, they're designed to break down those silos so that dev and ops can collaborate very, very easily. Now, DevSecOps is just an extension to that. It's nothing revolutionary beyond what DevOps is trying to do. It's trying to bring that security team in earlier so that we can break down those silos and increase the collaboration between developer and security teams. So how can we do this? Well, one of the ways in which we can do this is introducing security champions programs. Security champions programs are often used as an effective mechanism for communication, knowledge sharing, and collaboration between security and development teams. Now, it's important to start off by really clearly understanding the specific need that your teams have and the pain points that your dev teams are going through before thinking about and designing your Security Champions program. If you do not prioritize the needs of your development organization, you will not achieve organic developer adoption and the participation, which will really limit that program's effectiveness significantly. So a great first step would be to ask your developers what they want from the program. What are they struggling with in their day-to-day job, and how can you add value to their roles? To make their jobs easier and help them achieve their goals. Without providing them with this value, there's no value for them to join the program, and it would be seen as overhead. Another core distinction here is between a security champions program and a security community. A security community is a place for security curious individuals to share, learn, and improve their security knowledge. By contrast, Security Champions is an official formal program, an organizationally approved way to scale security practices and education and embed them deep into the developer organization, pardon me. So a pitfall to avoid is to run a Security Champions program without the executive support of both the security and engineering groups. This support empowers practitioners from the top down so that they can spend their time on the program and the activities therein, knowing that it's important and recognized by the upper management teams. The typical executive sponsors on the security side could be CISOs, security VPs, directors of product security. On the engineering side, that could be CTOs, VP of engineering. It largely depends on the makeup of your organization. Now, the timing of this sponsorship, depending on who we spoke to, varied significantly. Some people wanted that, found it most effective to have that at the very beginning, or some started with a pilot and then brought that to the upper management to show them what could be achieved to provide them with that executive support. So, what is a good security champion? And who is that? What does that person look like? Well, a good security champion is often someone who is generally interested in security, but ultimately it's important that a security champion is a developer. It's clearest when you have one security champion per developer or development team, or group of teams. But ideally, a developer should become a security champion voluntarily rather than something that is forced upon an individual developer. Now, that said, many companies that want coverage across their entire development organization will mandate that every team should have representation in the program. But ultimately, it's down to the team and developers to decide which one of them would want to join or should join that organization. So you might want to suggest the types of developers that you feel would fit well into a program based on the activities that they would need to be doing. The security team will also have representation in this program, of course, and that is typically through a role such as a security coach or a security mentor. A security coach would typically have a one-to-many relationship with a number of security champions, and that will naturally match the parts of the organization that they're responsible for in the security team. The role of the security champion isn't necessarily to do all the work themselves. In many organizations, in fact, they're responsible for making sure that the practices and procedures are followed, but it's important that others in the team go ahead and do the work for themselves. So monthly cadences for meetings for all champions to come together is quite common. In fact, pre-COVID, it was often seen that annual or 6-month in-person meetups were also done by some organizations. Now, what about the activities? Well, the activities that are most common included things like education, improvement of secure development practices, as well as vulnerability management. The most common education programs were a mix of internal training and external training, and also sharings that could be fed into a belt system. So a belt system is a really interesting way whereby, depending on how much training you did or how much investment you individually did in the organization, you would achieve a certain level of belt. This could be a brown belt or a blue belt or a black belt. You may want to have KPIs or expectations as well on how many black belts, brown belts, etc. you get as part of your specific areas of your organization. Now, improving your security in your development organization is a journey, and it takes time. And that starts with getting visibility into your existing security processes and practices that are typically done by each team. A great way of doing this is to ask your development organizations to complete a self-assessment scorecard of their team's processes and practices. Now, having the development team complete this allows good self-reflection time for them to do this without creating a them versus us dynamic that the security team is effectively asking these questions of the development team or grading the development team. Now, a scorecard is a set of questions that identify various security behaviors, testing types, processes, etc., and that allows the development team to state how much is currently being done and where it's being done. It's very common for teams to focus on certain areas and others want to care about other areas. That's perfectly usual. But the next step is always the same. How can we improve? How can we get the security team to help and support the development teams in that improvement? The key part is it's developer-led. It's developer-led improvement, and it's asking the development teams which items on the scorecard they want to care about, they want to improve. So whatever the goal, it's developer-led and owned by the development team. That's not to say the security group can't have an impact on that. They can also provide their information, their priorities, but ultimately it's the developers that are going to be doing the work in their teams. So let's use Snyk as an example of how we can gain that developer adoption in a program like this. As part of the scorecard process, we can get a picture of what's being done today regarding finding, fixing, and including Snyk at various stages of the process and the pipeline. You may be thinking that you know this already, but often what's being done that you think is being done and what is actually being done by the development organizations can sometimes be quite different. There are various activities that can be brought in to introduce Snyk or grow Snyk usage within teams, but it always starts with visibility. For example, you might want to import many projects in to start off with and see what your baseline is like across the organization, what your backlog looks like. But in order to achieve that developer adoption, it's about getting developer adoption into the developer workflow. This includes places like Git repositories or CI. That's an interesting place to start. Now, using the Git repo integrations, developers will start getting visibility into the impacts that their changes are making from a security point of view. And as time progresses, you can use the Champions program to educate secure development practices and encourage developers to identify these issues earlier in the IDE or CLI and recognize when they're delivering insecure changes that are against the policy set by the wider security team. This expansion is, of course, a gradual process that requires buy-in from developers, and buy-in from developers demands great developer experience. Now, Snyk achieves this because it's so fast that it fits into all stages of the pipeline with very, very little overhead. It reduces frustration by providing actionable, accurate results and speeds up the development process overall. So, what about successes? Rewards, recognition. Some people care about their career and have a career improvement through a Security Champions program. Many look to other perks such as physical meetups, somewhere nice perhaps, or tickets to a security conference like DEF CON, Black Hat, DevSecCon. Internal recognition is also very, very important. Mentions by your VP, which is very often seen widely by your management teams, or perhaps an internal company conference is a great way also to be a great advert for the Security Champion program. And of course, who doesn't like t-shirts, hoodies, something that allow people to feel that belonging or association with the group. Now, celebrating success is a crucial activity to help encourage good practices, as well as to share achievements of onboarding projects to be tested by Snyk, for example, or introducing and working new processes and policies to reduce backlog, perhaps, those kind of things. We want to be able to celebrate those and show where our successes lay. Now, this doesn't just justify and award the individual or team or based on their actions, but it also shows others a path they can follow, one of the paved roads to be inspired to follow and do the same. So Snyk is a great example of a tool and a process that can be added into a Security Champions program and easily adopted by developers through that engineer-to-engineer interaction. So, that is everything I had. Thank you very much for listening. If you want to read more about Security Champions or Snyk, of course, visit the Snyk.io website where we have loads more information about that. My name's Simon Maple. Thank you very much for listening and enjoy the rest of Snyk.